Now, don't tell me you're taking all this seriously.
Test. Good evening. We are going to continue working on optimizing this physics engine. So what we found out before was that 1,000 of these circles with no optimizations only runs at around 30 FPS. You can see here. So this is at, hey, said who? So this is using 1e-4 precision, which is very precise. So I can actually make this faster by decreasing precision. The issue is, with the way I have the physics engine currently working, is when I decrease the precision, it ends up making everything farther apart because the precision adds an invisible boundary. So you can see these things are stuck apart kind of, and you can also see it's way higher up because there's more distance between them. You can actually kind of see there's like an invisible boundary around them. So I can actually fix this. So that's the first thing I'm going to look at. But the other thing you can see is now it's running at 50, nearly 50, 45. So decreasing that precision helps a giant amount. It's basically the equivalent of decreasing the epsilon and ray marking, or increasing the epsilon. It's decreasing precision, but increasing, I don't know, step size. Minimum step size. I'm so happy I got all this working though. I gotta delete all this old code. Or, yeah, so this still isn't optimized. This is still like, I wrote this just for testing, and now I actually have to go through and refactor it and make it look good. But first I'm gonna fix up this little stuff, like, and I'm gonna optimize it. So that's the other thing, is right now this is just looping through every other body, which is very unoptimized. So I'm going to sort it into a grid, and then that'll make it so that I can really quickly get the nearby colliders. Just going to go to sleep in a bit. Hey, you're kind of getting back to normal people's sleep. That's actually a normal time to go to sleep. So what I have to do is right here, when I check the distance, it's smaller than this epsilon. I have to do something, either modify this distance or modify the step size right here. Think about this. Can you help me figure out a bug? Maybe, it depends on the bug. It won't take that long. I can't really say that until it's figured out. It's a shader toy bug. That's scary stuff then. What's the bug? Issue with the DirectX 9 backend is errors. Oh yeah, one sec. Oh my god, the music is way too loud. Here we go. Okay, so... Dude, oh my god, holy shit. I'm trying to copy... Holy shit, the Twitch app on my phone doesn't let you copy links. Holy shit. That's the most aggravating thing I've ever seen. Oh my god, the one thing I want to do with the link is copy it. Oh god. So I have to open it in the browser and then copy it from the browser. It's fucking good shit, dude. And so you know what I needed it for? All I wanted to do is this. So that I could repost it and open it. Oh my god. Yeah, there we go. There's the error. Warning, POW-FE will not work for negative. These are all warnings. Error, array reference cannot be used as an L value. Okay, it's not... Is it going to tell me what line this is happening on? See, this is what I hate about these DirectX errors, is it's not saying what line this is happening on. Okay, you said it was in the pathfind function, though. Array reference cannot be used as an L value, not natively addressable. I don't know. I guess there's limits to how you can address arrays. I don't know what to do. I'm guessing that's just the limit of the angle or whatever it's doing. happens because Pragma optimize on. Holy shit, that just... Oh my god, what is happening? Man, DirectX 9 is fucked. No, what's even more fucked is the fact that Firefox and Google Chrome are still using DirectX 9. Where is this Pragma optimize? Nope, still doesn't compile. Oh my god, how does it not give you line numbers here? No, that's all. Oh, wait, what? Wait, it has the error, but it's running? That's, Huh. Yeah, I can't do anything, it seems like. Yeah, it's weird how it wasn't running before and it just all of a sudden started running there, though. Anything else you want me to try? Maybe it's define vector. So, have you tried running Firefox from Wine on Linux? What part of define vector? Inlining struct causing it? I have no idea. Doesn't say anything about structs in here, I don't think, though. And, like, that's my thing, is if you had what lines these were happening on, then you comment out line 414 will work. Yeah, there it is. That was weird, the text just disappeared. There's something buggy about this web page right now. Try to use an immediate struct. Yeah, how do I change that though? Yeah, but where do I change that? I don't know what part of the pathfind function is even using that. .414 is just a pathfind function though. It's not the actual part where the structure is used. I'm gonna reload this. It's bugging the shit out of me that he's flashing. Alright, here I'll comment out all the vector instructions. There it goes. So it's something in the vector push and pop function. Oh wait, what type is size T uint? Okay, so it's not the uint, because then it would be something there. It's something about these vector instructions right here compared to this. This vector instruction for some reason is fine, but these ones in the loop, open chords, current chord, I think it's just the shader language is limited to how deep the instruction, the ray references can be. Yeah, exactly, just how deep it is in the loop. I don't know any fix besides saying not to use angle. Well, I guess I'll have to tell people to disable angle. Yeah, shit. says loop unrolling not possible. Apparently it always tries to unroll loops. Yeah, that's an angle thing. Oh, okay, so this is gonna be easy. Check if this is below or equal to 0, and right here we add the epsilon, or the precision. So now they shouldn't be any closer. Oh yeah, it looks better. I want to see how does that affect the frame rate and everything though. Oh yeah, 50 ticks per second, awesome. So let's try going back to a low precision. Let's see how it affects it now. Yep, still basically the same. Actually, I still think it's less compressed. Or more compressed, I mean, sorry. Oh yeah. So the lack of precision definitely results in an added space. This is still better though, they still get close together. Oh shit, one just flew out. Okay. So something about this is bad. Something about this isn't working properly. Because at least the other version before never flew through walls. I think it's probably this, pushing it through. Okay, what would be another way of doing this? Okay, so I actually think it's working correctly, but I think what's happening is that they're actually traveling too far inside of each other. I don't know how to explain it, like traveling inside of each other, and then this pushes off from the normal, which ends up squeezing them into the wall. So before, when it just compared to the epsilon here, it would never go far enough, I believe. I should actually make the walls a different color just so it's easier to see. Oh yeah! Look, you can actually see them going through the wall there. The for loop has to use constant expressions. Yeah, that is a very regular thing in DirectX 9. Okay, I'm gonna change the color of these to make it more visible when a ball goes out. Oh no, it's happening a whole bunch. So I don't think this is actually an issue with this. It's an issue with this right here. Pushes off from the normal. I'm going to try this. They still seem to actually be going into the wall a little bit. You can actually see. Okay, so I think this is actually good. So they shouldn't pass through the wall until the precision gets bigger. Oh no, one just went through. They shouldn't be passing through the wall until the precision gets bigger than the radius. Wait. Let me calculate this actually. Whoa, why did it just go up to 50 ticks? That was weird. I guess it was lagging and it compensated. I'm waiting for some other balls to go through. I should actually add a thing that counts how many fall through. I shouldn't rely on me watching for it. Yeah, I almost think this is actually not conserving energy. It's hard to tell though, but it seems like they're getting faster and faster here. That might be the actual way it's supposed to go though. Alright, so I'll add right here a part that counts the number that have gone out. So let me just make sure 0, 1, 2, 3, 4, 5. Okay. So yeah, the balls start at 5, so we need to check the object position has gone out of range. Then it'll have gone out. I might have a fix. Oh yeah, so to fix it, you can just do a constant loop of a giant size and then an if statement checking if it's gone through the how many iterations it already needs to go through. Basically, instead of breaking out of the loop, you just check if the loop is done yet and keep doing the loop. So let me check this. Physics epsilon of 1e negative 2. 1e negative, just to make sure, 1e negative 2 is 0.01, right? Yeah, so 0.01. The radius of the balls is 0.02. So is maybe the max radius or max precision needed before it flies out is half of the radius? I could actually be wrong about this math. Let me think about this. So if it's got this extra boundary around it, can you try it? Yeah, 1 second, let me just test this. Or finish doing this. So then if those are intersecting, but the actual bounding circles aren't, I think you could test this on Linux though if you opened up Firefox with Wine. So wait, if this is half, what does it look like? Okay, yeah, I completely see how this happens. No, it uses a while loop and I do the rest of my logic myself. Ah, okay. Nope. Wait, did it update? It looks like it's still doing a for loop. Here we go, awesome. So now it'll count if any go out. You actually see a few there where... So one of the things I'm going to do as well is I'm going to lower the velocity a whole bunch so that I can see whether or not it's gaining velocity. I'll have to change all those. I shouldn't have to, right? I don't know. It depends. Okay, so what I think what's happening actually is a lot of the velocity is concentrating or whatever in these down here. And then the few ones up here that are free get the bursts of energy from down here. The real test, yeah, will be... So 0 balls are going out now. So that's good. Vector pop, I changed that. Ah. Like I said, I don't know what the exact problem is. My god, it seems like this music just gets really loud all of a sudden. Okay, I'm gonna try lowering the precision even more to the same size. See if they pass through each other now. They probably should. Oh yeah, there they go. 9 balls gone out, 16, 26, 38. Oh yeah, look at them all go. Let's get a demo of pressure from gravity. Seems a lot like that. You're right. I'll just go to sleep. I've said it before, sleep is like one of the #1 things that helps me. Can just set my browser back to use angle and debug it. Yeah, I hate bugs like this. I'm tired too. I hate bugs that are basically just like the technology limiting you. Wish you could just tell Angle somehow to never unroll loops. I'm pretty sure you could do that in actual DirectX 9. Alright, so I'm going to give these guys much lower velocity now. Actually, I'm going to give them no velocity. And this should say if they're getting energy from nowhere. Because the velocity, so the bounce should, all their velocity should just be from their height. So the balls shouldn't go up here, I don't think. That would mean that they're gaining energy somehow. It seems like they're actually getting lower. Oh, okay, good. It's, as far as I can tell, everything's working properly. It's so cool too, because I'm 99% sure if I rendered this with a meta blob type thing, meta ball, this would look like fluid. 100%. Okay, so now I'm very happy with that. That I know everything is basically working as expected. Now I just want to measure where is the limit for the precision of where it starts to go through and fall through each other. So I know at half the radius here, sometimes every once in a while a ball will go through. But what about 75%? I'm guessing a few are going to make it out. Oh yeah, you can see them actually going through. There we go. 2 gone out, 5 gone out, 14. Okay. So I'm pretty sure I figured it out. Half of the radius is like it's that point of it's the place where it starts going out and starts running into bugs. The other thing that's really interesting is since it ends up making things hit each other slightly earlier, it ends up making them farther apart, it seems like, which is really interesting. So let me try just below that half, the radius. So yeah, you can see they're higher up still, but none are going out. Alright, so one of the things I want to see here is if the precision is what's causing the issue of them gaining energy. So if I leave these running with a low precision and they end up gaining, I'm okay with the lower precision behaving a bit differently. That's basically how it should work. It would be kind of crazy if you could lower precision and it made no changes on the simulation, but as long as it doesn't gain energy, as long as it actually still conserves, then it's good. Also, as far as I'm aware, this is completely deterministic, so that's also very good. Well, not completely deterministic. Cosmic rays make that much harder. Alright. There's one little thing I wanted to test here. Oh yeah. Adding this back to 2 and seeing if they end up flying out more. Or if it actually makes it less, and see if it makes the simulation better or worse. Oh no, yeah. So that makes them fly out way more. I want to see how it changes. I want to see if it affects the velocity. I almost think that the balls might bounce off each other. Not as hard, but actually no. Okay, that's super cool. And then if I do half, this should probably cause issues of them getting stuck in each other. Yeah, you can kind of see the balls are getting kind of stuck to the wall. So yeah, so that's having 0.5 repulsion instead of the full. So okay, I just want to check and make sure that they're never getting stuck to the wall even with this 1. Because that's kind of why I had it 2 instead of 1 before. Nope, it's good. Oh, this is great. Okay, so now I'm gonna add the grid optimization. So we are gonna stress test the shit out of this physics engine tonight. Okay, so let's see, 10,000. I think, yeah, this won't have enough space. Yeah, the issue is it won't place. I don't even think it probably doesn't have enough space for 10,000. Oh, yeah, there we go. Oh yeah, so it has them stuck in each other, it looks like. Or no. Oh my god, it's running at such an incredibly low frame rate that you can see them processing one at a time. It's going to take forever to come up here with the frame rate result. This is why I'm optimizing this. Oh my god, how long is it going to take? Alright, I did not expect it to take this long. You can see, like, this particle up here. Looks like it hasn't moved. It's moving very slowly. Oh god, this is brutal. Oh god, it's still not done. Okay, I'm just gonna start writing the optimization code. Anyways, I want this benchmark so that I can actually see how much better it gets. Once I add the optimization, I'm gonna run it with the 10,000 particles as well. And we're gonna see how it runs. So I'm gonna change how this works. Oh my god, it blows my mind this hasn't even run 50 frames yet. I guess 10,000 times 10,000 though. It's like million, 100 million, then times 50. processor can do like 500 billion operations. It's 500 million as far as I'm aware, so yeah, it still shouldn't take this long. Actually, yeah, that's operations. So then this is doing like 10 operations for each of those. There it goes. 0.239 ticks per second. Jesus Christ. Okay, need to write that down somewhere. So instead of 50 ticks per second, 0.239. Oh god. Alright, so instead of sorting it by layers, I'm just going to have a list with all the bodies, and then I'm going to have a grid structure. Okay. There's a few things. Okay, first of all, I have this option, I think, in the renderer. This is like off track, but if not defined, Q count. Okay, yeah. So I wanted to make sure that this was redefinable. That just came in my brain, but I think I'm going to do a define for the grid size, because different worlds will be optimized better with different grid sizes and sizes. And world sizes, so then I'm also going to need grid or bucket size. I don't know what to call this. Technically, it's like the max radius. And then the other thing is, do I want to make the grid from -1 to something, or do I, yeah, no, I'll make it normalized to -1. Alright, so then I want some flag for saying whether or not a component what's a quick way I can check if a component is a collider or rigid body. I don't really want to add a boolean right here, but I might have to. Or that is the quickest way. Otherwise I'll have to get the component data and compare the pointer, and that's way less efficient than if I have a boolean. Oh, so then I actually probably don't need this Boolean of whether or not this is a body, because I can just check is collider here. Yeah, so I can change that. I'll do that later. That's not like an optimization issue. Alright, so now a grid of lists, and each of these will hold colliders and bodies. And so then I think I'll need a list as well for bodies and colliders that don't fit in the grid. Alright, so now I gotta initialize the list, or the array of lists. There we go. Alright, so that initializes physics2D. So now we need to change this. Okay, so actually this is going to be the complicated part, is calculating where and when in the grid a rigid body is. So the rigid bodies are going to be the most complicated part as well, because they move. So I'm going to need to quickly update the grid position. Alright, so I'm gonna I'm gonna save here the last grid position. I'm gonna do the same thing with the collider 2D. And then I'm gonna check when that changes. So if the grid position is uint max. It's currently not in the grid. I'm going to ignore Collider 2D for now because all this oh wait, actually never mind. I was going to say all this test is doing is rigid bodies, but it does have the floor and walls. Okay, so now I'm going to create a function, rigid body, update grid position. So this will update the grid position once it's changed. And I might actually make this out of a function. I don't know, I'll write it in a function first. Alright, so the position minus the grid left and top gives me the space or the grid space position, or okay, then scaling that by the size of the grid space. That gives us a grid position. Alright, so then if either of these is outside of current bounds, oh man, so I'm wondering here, do I want to update the position as it moves? Yeah. Yeah, so actually I'm not going to make this a function, I'm going to do it differently for each part of the code. Just because this is something that's going to be called multiple times, many times per frame. I want it to be as optimized. Awesome, okay, there we go. So now this will add to the grid. Alright, now I just need to remove it from the grid. So the one thing with this method is that if objects go outside of the grid, or rigid bodies, everything stops working. So it's a lot more optimized, but it's also limited. A lot more limited. But realistically, your game is going to have a limited size anyways, or map, so... Alright, so now I'll implement it in this distance function. I'm going to comment out and save this old code just in case I ever want to go back to it. Alright, so the first part of this is calculating what the current grid X and Y is, and then iterating over the surrounding blocks. Or grid cells. Excuse me, I just burped. So then I've got to check if this is actually out of bounds. Or if this isn't out of bounds, then skip. wonder if the and or is faster. Maybe or. All right, there we go. So that gives us the grid list. Then we need to loop through this. Oh, maybe I should put the layer mask right here. Just so that I can much more efficiently compare this without having to go to the object pointer. And I feel like I should actually put this function in the collider 2D because it really is a collider. So instead of doing that to the layer, what if I calculated the layer? Alright, so now I have to actually do this calculation. Okay, so now we need the collision code from here. Instead of TB, it's RB. Yeah, so then I don't even know if I need this distance sample anymore. So this way though, I'm gonna need to pass a pointer here. Unless I do actually. If nearest does not equal null. There we go. Alright, awesome. So now our nearest function is updated. Oh wait, okay, so I also need to loop through the colliders. So these would actually be colliders that are too large to fit in the grid. Okay, hell yeah, that should be good. So now I need to change this from looping through the layers to just looping through the bodies. And then when I update positions here, that's when I update the grid position. Alright. Hey, Zenka plays. I just need to check. This is only being called if it's actually updating, right? Yeah, okay. I thought you would appreciate it. I mean, by definition, dad jokes are kind of old. Not the joke, but the effort of coding a bot for that. The question is, how many jokes are there? Alright, so now that we have the new grid position, we check if the grid position is different than the existing one. No audio on my side. Huh, everything's good. Touching Node.js for the first time today. Ooh, how was that? Node.js is kind of like it's like a hype language. It's like there's tons of hype around it, but it's not like a actual decent language, at least in my opinion, or platform, I guess I should say, because it's just JavaScript. Alright, so if the grid position's changed, then we need to change the grid entry. Except if the grid entry is uint max, then there's no grid entry, so we don't have anything to remove. The original idea was for the bot was to get that as an array. People in chat. It's not your chat. Oh yeah, okay. Alright, there we go. So that updates it. That actually should be everything I need now. So let's see if this even compiles. I'm guessing there's going to be errors. Yep. Oh yeah, I forgot to change this. Distance function. Where is it? Object is not a member. Oh yeah, it's base.object. Wait, what? Undeclared identifier? Oh. RGIDI. Oh yeah, and it's not is body, it's is collider. I'll switch these code sections around so that it actually matches up. Alright, function cannot convert from list to list. Oh, that's supposed to be and. Alright, yes, this should be it. This should compile. Alright, I'm interested to see if this is going to run and how well. Okay. It's hard to tell if it initialized quicker or slower. Okay. So the first thing is it didn't crash, which is very good. But the other thing is I don't have the grid size currently optimized. So let's do that. So we're going to want the grid to be focused from -1 to 1. So I think grid size of 32 is good. But we want the grid gap to be 2 divided by 32. So that way it'll split the grid. What's 32.0? So that way now there should be way less. Oh, it crashed. Alright. Very good test. So something about this. Okay, so all of that is good. There's something I'm gonna comment out the sections of code. Okay, so actually if it crashed at the beginning, it should be this distance function right here. Oh, or it's when it's adding. Oh, oops, I forgot to break out of this. Ooh, it's spawning them off to the side. I gotta fix that. So that makes me wonder if these are 0.05. Oh, that's 9.5 instead of 9.8. So now with the distance function there, does this make it crash? Okay, that's super interesting. So actually, even with no collisions, huh, that's so interesting how sometimes... Is this what decides if it crashes or not? I don't think it should be. Okay, so sometimes... I guess it's this right here. Anyways, I want to check how many ticks per second it can get with no collisions. I'm actually going to be... Like, I'm actually blown away if... That doesn't make sense. 10,000... It should be able to process 10,000 50 times a second. Alright, so all this is doing is looping through the rigid bodies. I would think it would be able to do this. No, 20 ticks. Oh my god, my expectations. There has to be something wrong here. Because literally all it's doing is just adding gravity. I'm actually really determined to optimize this now, even without collisions. I'm also curious, if I disable the renderer, how much faster does this make it? Could the lag be coming from the renderer? "35 ticks per second. Oh my god, the renderer added 15 ticks off. Whoa. Alright, so calling update transform is going through update blit main. It's adding a single renderer call. Oh my god, I'm wondering if making this single threaded could actually make it faster. I think the delay is coming because, or the delay is from the synchronization with the rendering. Because the rendering is on a separate thread, anytime it has to update the renderer's uniform data, like the position each time the rigid body moves, it needs to operate on a list that's synchronized between the render and update thread. Synchronization is a huge thing. So yeah, I can actually, if I go into the GUI code here, where it's actually updating and doing this render call here, so yeah, exact same effect. Now I'll go even further. What if I leave the render call, but actually disable all of the operations here on setting the uniform data? Oh my god, this is so interesting too, because I was benchmarking this. This is making me go back to think about my benchmarking for this GUI that I actually did on the text rendering. So the key part of the text rendering was, though, is I was practicing updating 10,000, actually I think it was like 100,000 objects right here, except it does all of this processing. The main update text is just one render call. It does the thousands of processing in a loop on the render thread, so it actually doesn't need to add thousands, which is, I believe, where most of the lag should come from. But here's my other test. If I disable this actual part where it sets up the data, I'm going to try disabling the different parts and see how much of an optimization I get. Okay, so first of all, actually, I'll disable all of this. So this way, it'll tell me if I still get the frame rate drop, it'll tell me that this is just the synchronization. If I don't, yeah, I still get the frame rate drop. Okay, so it's the synchronization between the rendering thread and the update thread. That is so interesting. Oh man. I don't know what to... I don't think there's anything I can do about that unless I separated it to a single threaded... Yeah, so unless I update it to a single threaded rendering system, which I don't want to do, because then the other issue is that your OpenGL calls still do have a little bit of a delay. Alright, well this is so good actually, knowing that this is now getting throttled by the rendering. So now I know that 20 FPS is actually going to be the maximum. Okay, so let's try and get this physics optimized now. So we still know before I put the little comment up here, 0.239 ticks per second without optimization. Okay, so now our goal is going to be getting this working without any crashing or anything. Alright, I gotta find what part of this is crashing. So the other main thing is to realize that even if 10,000 is really slow for this, the GUI is never, I don't think it's ever going to have 10,000 objects updating at once. And if it is, I can create some custom system like the text, where it says they're all updating. Okay, what is happening? Oh, I guess because they aren't colliding with each other. Alright, I gotta figure out why it crashes though. I do think it's this part right here. I guess not though. I'm pretty sure it's this physics 2D distance right here. Man, now I'm actually thinking about like how I could optimize doing that. I'm actually thinking of making all of this single threaded now, except for the physics, because like the physics, for example, I know can be on the other thread. Oh man, it's so funny how you can go and make something multi-threaded and ends up making it slower due to synchronization. The main thing is this should mainly only be slower if there's thousands of objects moving. But that's the crazy thing, is you do want to support thousands of objects moving. I'm really thinking I might rewrite this to be single-threaded. Yeah, I'll look at doing that. Anyways, let's get this working. Let me make sure this isn't what makes it crash. So let me see if it crashes without calling this. Nope. We're good. Okay. So now if we call this... Yeah, it crashes. Okay, so we need to find out why this is. Alright, I'll try commenting out this part where it goes through the loop. See if it's that. Man, that kind of bummed me out that the multi-threaded rendering is slower. Yeah, so I guess it was that, something here. Negative. What was happening there? Oh, it's doing GX instead. There we go, okay, and it starts up way quicker. So now hopefully this should work here as well. It's just they won't collide with each other. Oh my god, did I not uncomment the part that updates it? Wait. Why are they not moving? I guess the colliders? Okay, what's going on here? Distance. I'll put the distance console. Oh my god, I'm not calling the update function. Of course. I should have realized. Alright, so 20 ticks. I don't know what's happening to them. I don't know why a majority of them are getting stuck or stopping down there. I'll have to figure that out. I wonder if that's an issue with this precision. Oh my god, it is. That's so cool. Okay, so I'm actually going to need to do tests to make sure this works properly. I'll do that though once this is optimized and fixed. So now that I know this is working, let's add in the actual collision checking. See how much faster it is. Wicked. It's working. Oh my god, look at it. 10 ticks per second. I want to see what the memory usage is like on this too. 30. 38 kilobytes. Pretty good. So the memory usage should go up as I increase the grid size, but it should make it faster. So now I'm curious. This is 1 or 2 divided by 32 grid size. I believe since these have a radius of 0.03, I should be able to do a grid size of no, actually maybe 32 is the highest. Or actually 64. So let's try and see how much faster this is. $13, amazing. So now it uses 45 megabytes instead of 38. And yeah, so you can see it's using 18 of my CPU even though it's running rendering and CPU on separate threads. We can see that the CPU thread is maxing out and the rendering thread is not. And then we can see that if we disable the rendering, which stops the synchronization between the threads, it stops throttling the CPU thread. Runs at a full 30, 28 ticks, which is still really good. Oh my god! And that reduces the memory a giant amount too. Yeah, so I'm really gonna look at redoing how this rendering and everything is separated. See if I can take advantage of these. Anyways, this is amazing. I was able to get like 30 times up to actually 100 times speed increase if you include the rendering optimizations, if I can get those included. So let me actually see, just disabling the rendering components completely, what does that do? No, yeah, it's still limited. So I want to see too, how does the grid size affect it? It doesn't seem to get that much benefit between 32 and 64 grid size. Let's see how it affects it without the rendering. Yeah, so it generally just makes it slower. Okay, so that's so interesting. So here, it's actually running at the same rate as it did with the rendering. So you know what? I don't think this is as bad as you can actually see here now it's starting to throttle the CPU. Alright, so then that's actually not so bad. The difference between rendering and not rendering is it's basically running at 10 ticks per second with or without rendering, which is actually really good. I'm pretty happy with that. See, my other thing is once it gets into VR, I think you really want rendering on another thread where the head and everything is going to potentially be going at 90 frames per second. But yeah, I'm definitely going to look at switching around how the rendering works and see if I can get it faster. And it'll also be so much easier if it's all on the same thread. So that's the other crazy thing, is the only reason I was dealing with being on different threads being more difficult was because I thought it was faster, but if it's actually slower, the problem is like you really can't update the render data from the update thread without synchronizing it. Anyways, that'll be the stream tonight. Oh my god, I'm so happy with this. This is like going insanely good. It can do 10,000 objects. And now that I'm realizing that how big of an effect a large number of objects actually has, it's really making me question, like the other thing I said is having it on the other render thread isn't always worse either. Like I said, the text is actually faster because it does that large processing on the render thread. So if I have large things like these particles, I could make custom code to do it on the render thread. Like, that's probably what I'll do for particle systems. Oh man, this is so good because now tomorrow I can work on extending this to 3D. Thanks for watching the stream today. I hope you enjoyed it or learned something. Hope you have a good night wherever you are. See you around. I'll be back again tomorrow for more C Game Engine programming.